Iranian naval doctrine was not designed to defeat the United States Navy in a conventional engagement. It was designed to make victory so costly that the United States chooses not to fight. This is the scenario that keeps Pentagon planners awake. In this hypothetical scenario, wargame analysts suggest that any attempt by the Islamic Revolutionary Guard Corps Navy to close the Strait of Hormuz would result in a high-intensity engagement that would test the absolute limits of modern naval technology. If this engagement were to occur, the primary Iranian objective would likely not be the total destruction of the American fleet, but rather the neutralization of its primary power projection tool, the aircraft carrier. On one side of this hypothetical battle space is a United States Navy carrier strike group, based on known capabilities. This force would likely consist of one Nimitz-class or Ford-class aircraft carrier carrying over 60 aircraft, including FA-18 fighters and F-35 Charlie stealth jets. Escorting the carrier would be at least two Arleigh Burke-class guided missile destroyers and one Ticonderoga-class guided missile cruiser. These vessels are equipped with the Aegis combat system, which integrates the AN/SPY-1 or the newer AN/SPY-6 radar to track hundreds of incoming threats simultaneously. Their primary defense consists of a layered shield of Standard Missile 6 and Standard Missile 2 interceptors, capable of engaging targets over 100 miles away. Opposing them is the Islamic Revolutionary Guard Corps Navy, a force built specifically for asymmetric warfare. Defense. Analysts have modeled an Iranian attack consisting of over 100 fast attack craft. These small vessels, often less than 40 feet in length, would likely be armed with short-range anti-ship missiles, rocket launchers, and heavy machine guns. Unlike a traditional navy that relies on large, expensive platforms, Iranian doctrine relies on saturation. If these forces were to meet in the narrow waters of the strait, the Iranian goal would be to overwhelm the Aegis system's fire control channels by presenting more targets than the American defenders have interceptors to fire. In this scenario, the geography of the strait would likely become the most significant factor. At its narrowest point, the shipping lane is only 2 miles wide. This geographic restriction would limit the maneuverability of large United States warships, making them more vulnerable to coordinated strikes from both the sea and the shore. Analysts suggest that the combination of sea-based swarms and land-based anti-ship cruise missile batteries creates a dual-threat environment that has never been fully tested in a high-intensity combat situation. If this engagement were to unfold, the central question for defense planners is the magazine depth of the United States escorts. While a destroyer carries 96 vertical launch system cells, only a portion of those are dedicated to air defense. If 40 fast boats were to approach from different vectors while 20 cruise missiles were simultaneously launched from the coast, could the Aegis system intercept every single threat? Based on historical precedent and current naval models, even a single successful hit on the aircraft carrier would likely result in a mission kill, effectively rendering the flight deck unusable and forcing the ship to withdraw from the engagement. In this analysis, we examine what would likely happen if these two opposing naval philosophies collided in one of the most contested waterways on Earth. Wargame models indicate that the outcome would not be a simple matter of technological superiority. It would be a brutal test of how much damage a modern carrier group can sustain before its mission is compromised. This analysis is based on publicly available information regarding weapon systems and known military doctrine. Real outcomes would depend on factors no model can predict. But the data suggests that a conflict in the Strait would likely be the most violent naval engagement since the Second World War. In this hypothetical engagement, Analyzing the capabilities of the Islamic Revolutionary Guard Corps Navy requires looking past conventional metrics of naval tonnage and displacement. If these forces were to meet, the Iranian side would likely rely on a force structure that emphasizes speed, mass, and geographic familiarity over the heavy armor and long-range endurance of the United States Navy. Defense analysts have modeled the primary threat as a combination of highly mobile sea-based platforms and integrated land-based missile systems. At the heart of Iranian asymmetric doctrine is the fast attack craft. In this scenario, the Islamic Revolutionary Guard Corps Navy would likely deploy a mix of Zulfikar and Siraj-class vessels. The Zulfikar is a fast patrol boat based on British hull designs, capable of reaching speeds of over 45 knots. While small, these vessels are far from primitive. They are typically armed with two C-704 anti-ship cruise missiles. If a swarm of 50 such boats were to launch simultaneously, it would create a saturation environment involving 100 incoming missiles from multiple vectors. Furthermore, analysts suggest that the Siraj-1, a high-speed interceptor based on the world record-breaking Bradstone Challenger hull, would likely be used as a harassment and distraction platform. These boats can reach speeds exceeding 60 knots, making them incredibly difficult for traditional naval gunnery to track and engage at close range. In this hypothetical engagement, these interceptors would likely be used to draw the fire of the carrier group's close-in weapon systems, potentially exhausting ammunition or creating sensor confusion just as the heavier missile-armed boats close in. The Iranian side also possesses a significant technological advantage in its home waters through the use of shore-based anti-ship cruise missile batteries, based on known capabilities. These would include the Noor and Qatar missiles, which are Iranian developments of the C-802 design. These missiles have ranges between 70 and 150 miles, allowing the Iranian command to launch strikes from hidden, hardened positions within the jagged coastline of the Musandam Peninsula or the hills of the Iranian mainland. If these land-based batteries were integrated with the sea-based swarm, the United States Carrier Strike Group would likely face threats from 360 degrees. It is a common misconception to view these forces as disorganized. Doctrine indicates that the Islamic Revolutionary Guard Corps Navy trains extensively for swarming tactics, which are highly coordinated maneuvers designed to exploit the physical limitations of the Aegis combat system. Wargame models predict that the Iranian commanders would likely wait for the carrier group to enter the narrowest part of the strait before initiating a pulse attack. This involves a sudden, massive surge of activity where every available platform fires simultaneously. The objective is to exceed the number of targets the AN/SPY-6 radar can prosecute at one time. In this scenario, analysts believe the Iranian crews would demonstrate high levels of professionalism and tactical discipline. They are trained to operate in the sea clutter, the noise and radar interference caused by waves and local traffic, which makes it harder for American sensors to distinguish a fast attack craft from a civilian DAGO or a wave crest. If this engagement were to occur, the Iranian side would likely accept heavy losses among its fast boat crews as a necessary trade-off for a single successful strike on a high-value target. This doctrine is specifically engineered to exploit the reload limitations of vertical launch systems found on United States destroyers. Once a destroyer has fired its complement of interceptors, the rearm process cannot be done easily at sea. Therefore, the Iranian force does not need to destroy every American ship. It only needs to survive long enough to force the American escorts to deplete their magazines. This is a sophisticated, strategic choice that treats the Iranian Navy not as a fleet meant to survive a war, but as a one-time use weapon of mass saturation. If this scenario unfolded, The Iranian side would also likely utilize sea mines, specifically the EM-52 and other smart mine variants. These would likely be deployed in the weeks or hours leading up to the engagement, creating kill zones that funnel the United States carrier group into predictable paths where the swarm could strike most effectively, based on observed exercises. Analysts suggest that this combination of mines, fast boats, and shore-based missiles represents a credible threat that cannot be dismissed by technological superiority alone. In this hypothetical engagement, the United States Navy would rely on a defensive doctrine known as layered defense, designed to neutralize threats at progressively closer ranges. Analysts suggest that the centerpiece of this defense is the Aegis combat system, an integrated collection of sensors, computers, and weapons capable of simultaneous multi-domain warfare. If a carrier strike group were to enter the Strait of Hormuz, every vessel in the formation would likely operate as a single, networked defensive node, sharing radar data in real time to create a comprehensive picture of the battle space. The outer layer of this defense would likely be managed by the carrier's air wing. Defense analysts emphasize the role of the E-2 Delta Hawkeye, an airborne early warning and control aircraft, operating at high altitude. The E-2 Delta uses its powerful circular radar to detect low-flying cruise missiles and small surface craft far beyond the horizon of the ships. In this scenario, the Hawkeye would likely serve as the quarterback of the engagement, directing FA-18 Echo and Foxtrot Super Hornets and F-35 Charlie stealth fighters to intercept threats before they could get within missile range of the carrier. Based on known capabilities, these aircraft would likely utilize the AIM-120 Advanced Medium-Range Air-to-Air Missile for aerial threats and laser-guided rockets for surface targets. Analysts believe that the MH-60 Romeo and Sierra helicopters would also play a critical role. These helicopters are specifically trained for surface warfare and are equipped with Hellfire missiles and heavy machine guns, making them the primary tool for thinning out a fast boat swarm before it reaches the escorts. If the air wing were to be bypassed or overwhelmed, the middle layer of defense would be activated. This layer is defined by the vertical launch systems found on the Arleigh Burke class destroyers and Ticonderoga class cruisers. The primary weapon here is the Standard Missile 6, or SM-6. This missile is highly sophisticated, capable of intercepting both high-altitude ballistic missiles and low-skimming cruise missiles at distances exceeding 150 miles. In this hypothetical engagement, the SM-6 would likely be used to target the larger Iranian command boats or incoming shore-based cruise missiles. Closer in, the defense would transition to the Standard Missile 2 and the Evolved Sea Sparrow missile, or ESSM. The Evolved Sea Sparrow is particularly vital in a swarm scenario because it is quad-packed, meaning 4 missiles can fit into a single vertical launch cell. This allows a destroyer to carry a much larger volume of interceptors, a critical advantage when facing a saturation attack. Wargame models suggest that the Aegis system's ability to manage these different interceptors simultaneously is what makes the carrier strike group the most defended maritime target in history. The final, or inner layer, of defense is comprised of point defense systems like the Rolling Airframe Missile and the Phalanx Close-In Weapon System. The Phalanx is a radar-guided 20mm Gatling gun capable of firing 4,500 rounds per minute. If a fast boat or a missile were to penetrate the outer and middle layers, these systems would likely activate automatically. Analysts describe this as a wall of lead designed to shred anything within a mile of the ship. However, defense analysts are quick to point out that even this sophisticated shield has honest vulnerabilities. The first is magazine depth. While a carrier strike group carries hundreds of missiles, they are finite. In a hypothetical high-intensity engagement lasting several hours, the escorts could likely deplete their most capable interceptors. leaving them reliant on shorter-range guns. The second vulnerability is littoral clutter. In the narrow Strait of Hormuz, the radar must distinguish between an Iranian fast boat and a civilian fishing DO. If the swarm mixes with civilian traffic, the Aegis system's automated targeting might be delayed, as human operators attempt to identify targets, losing precious seconds. Finally, there is the saturation threshold. Every radar system, no matter how advanced, has a limit to how many targets it can illuminate and track with high precision at once. Iranian doctrine is specifically engineered to find this threshold. If the Revolutionary Guard Corps Navy can present 101 targets to a system designed to track 100, that one unmonitored threat could be the one that reaches the carrier. In this analysis, the Aegis shield is not seen as an invincible barrier, but as a high-technology filter that must perform perfectly to ensure the carrier's survival. In this hypothetical engagement, analysts believe the conflict would not begin with a massive explosion, but with a sudden and chaotic degradation of the electronic environment. If these forces were to meet in the northern approaches of the strait, the Iranian Revolutionary Guard Corps Navy would likely initiate the engagement by flooding the area with noise. This would likely include a combination of high-powered electronic jamming from shore-based stations and the deployment of dozens of small, unmanned aerial vehicles designed to clutter the radar screens of the United States fleet. Wargame models suggest that the initial Iranian move would be to use gray zone tactics to mask the deployment of the fast boat swarm. In this scenario, the Iranian flotilla commander would likely order the hundreds of fast attack craft to mingle with the existing commercial shipping traffic that constantly transits the strait. By staying close to massive oil tankers and cargo ships, the smaller Iranian vessels would likely use the radar shadows of these giants to move into striking positions without being immediately targeted by long-range American missiles. Based on known United States Navy doctrine, the response from the Carrier Strike Group would be immediate and proactive. The Carrier Group commander would likely authorize the launch of additional FA-18 Super Hornets and MH-60 Romeo helicopters to establish a combat air patrol around the formation. Analysts suggest that the E-2 Delta Hawkeye would be the first to identify the anomaly, a sudden surge of high-speed signatures detaching from the merchant lanes and accelerating toward the carrier's screen. In this hypothetical opening phase, the first kinetic contact would likely occur at a distance of approximately 40 miles. If the Iranian forces were to launch a wave of drones or older, land-based cruise missiles as a distraction, the Aegis destroyers would likely respond with the Standard Missile 2. Analysts believe the United States' primary goal at this stage would be threat prioritization. The Aegis combat system would have to rapidly categorize hundreds of incoming signals, distinguishing between harmless decoys, commercial traffic, and high-threat anti-ship missiles. According to defense analysts, this is the moment where the rules of engagement would be most severely tested. In a hypothetical high-tension environment, the tactical action officer aboard a United States destroyer would have mere seconds to decide if a fast-moving contact is a civilian vessel or a Zulfikar-class boat preparing to launch a torpedo, if the engagement were to proceed. Doctrine indicates that the United States would likely issue a final warning over bridge-to-bridge radio before the first defensive salvos are fired. Historical precedent suggests that the Iranian side would likely wait for this moment of hesitation to launch their primary first strike. Analysts believe this would likely consist of a coordinated volley of shore-based Qatar cruise missiles. These missiles would approach the Carrier Strike Group from the Iranian coastline, flying just 30 feet above the water, to stay beneath the fleet's radar horizon for as long as possible. In this scenario, the flight time from the coast to the carrier group would be less than 5 minutes. As the first Standard missiles leave their vertical launch cells, the engagement would transition from a standoff to a hot war. The sky over the strait would likely be filled with the crisscrossing trails of interceptors and incoming threats. Analysis suggests that while the initial American defensive salvos would likely achieve a high kill probability against these first-wave targets, the primary Iranian objective, forcing the United States to expend its most expensive and capable interceptors early, would likely be achieved. This first contact would set the stage for the escalation to follow. As the primary fast boat swarm begins its high-speed run toward the heart of the strike group, in this hypothetical engagement, the transition from initial contact to full-scale escalation would likely occur within minutes of the first missile exchange. As the smoke from the initial defensive interceptions clears, wargame analysts suggest that the Iranian Revolutionary Guard Corps Navy would immediately shift to its primary objective, the saturation of the carrier strike group's defensive perimeter. At this stage, the engagement would likely move from a series of isolated skirmishes to a high-intensity, multi-axis assault. Analysts believe the escalation would begin with the deployment of the mass. In this scenario, the hundreds of fast attack craft that had previously been shadowing merchant vessels would likely accelerate to their maximum combat speeds, converge from multiple points of the compass. If this engagement were to occur, the United States fleet would find itself at the center of a closing circle of high-speed signatures. Defense analysts have modeled this as the saturation threshold, where the number of incoming threats begins to rival the number of available fire control channels on the Aegis destroyers. Based on known doctrine, the carrier group commander would likely be forced into a series of high-stakes tactical decisions. The first would be the allocation of resources. If 40 fast boats are approaching from the east and 30 from the west, while another 20 cruise missiles are detected launching from coastal batteries, the Aegis combat system must decide which threats pose the most immediate danger. In this hypothetical, the system's auto-engagement modes would likely be activated, allowing the computers to prioritize targets based on their speed, trajectory, and proximity. As the swarm closes the distance to within 15 miles, the United States Navy would likely transition its defense to shorter-range, high-volume weapons. Analysis suggests that the evolved Sea Sparrow missile, or RIM-162, would become the workhorse of this phase. Because these missiles are quad-packed into the vertical launch cells, they provide the magazine depth necessary to address a massed swarm. However, even with this advantage, analysts believe the reload cycles and the time required for a missile to travel to its target would create a bottleneck in the defense. In this scenario, the Iranian force would likely employ tactical decoys to further complicate the American response. Doctrine indicates that the Revolutionary Guard Corps Navy often utilizes unmanned fire ships, older vessels packed with explosives and equipped with radar reflectors, to mimic the signature of a larger combatant. If these decoys are mixed into the fast boat swarm, they would likely draw defensive fire away from the actual missile-carrying boats, forcing the United States to waste its limited supply of interceptors on low-value targets. While the surface ships manage the missile threat, the carrier's air wing would likely be engaged in a desperate thinning operation. Analysts believe that MH-60 Sierra and MH-60 Romeo helicopters would be hovering on the flanks of the formation, utilizing their 20mm door guns and Hydra 70 rockets to engage the leading edges of the fast boat swarm. In a hypothetical engagement of this scale, the workload on the pilots and sensor operators would be extreme. If the swarm is successful in reaching the 10-mile mark, the helicopters would likely be forced to withdraw or risk being overwhelmed by the combined anti-aircraft fire from the fast boats themselves. This is the moment where defense analysts suggest the human factor becomes critical. In the heat of a saturation attack, the tactical action officers aboard the destroyers must maintain a clear picture of the battle space while being bombarded with data. If a single coordination error occurs, if two ships target the same incoming missile while ignoring another, the resulting gap in the shield could be catastrophic. Based on historical precedent, even the most highly trained crews can suffer from sensor soak, a state where the volume of information exceeds the ability of the brain to process it effectively. As the escalation reaches its peak, the engagement would enter the inner layer of defense. This is the point of no return for both sides. For the Iranian swarm, it is the moment they must penetrate the final wall of lead to deliver their ordnance. For the United States Navy, it is the moment where technology meets its physical limits. In this hypothetical analysis, the transition from the middle layer missile defense to the close-in weapon systems marks the final escalation before the exchange of fire becomes a matter of survival. In this hypothetical engagement, analysts identify the 5-mile mark as the dead zone, the critical distance where the engagement shifts, from a high-technology missile duel to a frantic, close-quarters brawl. If the Iranian fast-boat swarm were to cross this threshold, the nature of the battle would likely change fundamentally. At this range, the time between a weapon being launched and its impact is measured in seconds rather than minutes, leaving virtually no room for human error or mechanical delay. Based on known capabilities, as the leading edge of the swarm reaches 5 miles from the carrier's screen, the United States destroyers would likely be forced to transition from their primary vertical launch system missiles to their point defense systems. Wargame models suggest that the Standard Missile 6 and Standard Missile 2 are less effective at these ultra-short ranges due to their minimum engagement distances and the high crossing speeds of the fast boats. In this scenario, the primary defensive burden would likely shift to the rolling airframe missile, or RIM-116, and the Phalanx close-in weapon system. The rolling airframe missile is a high-speed, infrared-guided interceptor designed specifically to track and destroy incoming missiles and small surface craft in the final seconds of their flight. However, a significant limitation identified by defense analysts is the capacity of the launchers. Each launcher on an Arleigh Burke class destroyer carries 21 missiles. In a hypothetical saturation attack involving 40 or 50 boats, a single destroyer could likely deplete its entire ready-to-fire magazine in less than 2 minutes. Once these are spent, the ship is dependent on the Phalanx, a 20mm Gatling gun. At the 5-mile threshold, Iranian doctrine calls for the fast boats to launch their primary ordnance. Analysts believe that dozens of Nasr-1 anti-ship cruise missiles would be fired almost simultaneously from the moving decks of the swarm. These missiles, while less sophisticated than their shore-based counterparts, are designed to overwhelm by volume. If 30 missiles are launched from different vectors within a 60-second window, the Aegis system must coordinate a perfect defense. The sound of the Phalanx guns would likely be a constant roar across the water, firing at a rate of 75 rounds per second to create a kinetic shield around the carrier. In this scenario, the Iranian flotilla commander would likely accept extreme casualties to ensure even a few boats reach the 3-mile mark. Defense analysts describe this as the attrition gap. If the United States Navy successfully destroys 90% of the incoming swarm, but 10% survives, those remaining 5 to 10 boats still represent a lethal threat. At 3 miles, the fast boats would likely begin firing their heavy machine guns and multiple launch rocket systems, not to sink the American ships, but to mission kill their sensors. The critical moment occurs when the Aegis radar arrays themselves become targets. A single lucky hit from a rocket or a heavy machine gun could likely crack the delicate face of an ANSPY-6 radar or destroy the satellite uplinks required for the fleet to share data. Analysts believe that if the lead destroyer in the screen is blinded in this way, its ability to protect the carrier is effectively neutralized, without the shield of the escort. The aircraft carrier, a vessel nearly 1,100 feet long, becomes an enormous and relatively defenseless target for any remaining Iranian missiles. If this engagement were to occur, wargame results consistently show that this 5-mile threshold is where the United States Navy's technological advantage is most severely compressed. The engagement becomes a race between the automated reload cycles of the American guns and the suicidal persistence of the Iranian swarm. Analysts suggest that at this range, the probability of kill for the defenders begins to drop, as the sheer volume of smoke, debris, and electronic interference from previous explosions starts to clutter the radar's view of the remaining targets. This is the moment that determines the outcome of the entire engagement. If the Aegis system holds, the swarm is annihilated. In this hypothetical engagement, analysts suggest that the sheer volume of a coordinated swarm would likely result in at least some ordnance penetrating the carrier strike group's defenses. Even the most optimistic wargame models predict that a 100% interception rate is statistically improbable in a high-intensity saturation environment. If this scenario were to unfold, the exchange of fire would likely result in significant mission-altering damage for both sides. Based on known capabilities, the first American loss would likely be the full combat effectiveness of one of the escorting Arleigh Burke-class destroyers. In this hypothetical, if a wave of 30 Iranian fast boats were to launch their Nasser-1 missiles simultaneously, at least one or two would likely find a gap in the defensive fire. Analysis suggests that a single hit from a 300-pound high-explosive warhead would not sink a 9,000-ton destroyer, but it would likely result in a mission kill. If the missile were to strike the superstructure, the blast would likely destroy the ANSPY-6 radar arrays and the satellite communication domes, effectively blinding the ship and removing it from the networked defense of the carrier. Wargame analysts believe that in such a scenario, the aircraft carrier itself would likely become the target of a leaking threat. If a shore-based Kater cruise missile were to bypass the distracted escorts, its impact on the carrier's hull or flight deck would be catastrophic for the group's mission. While the massive displacement of a Nimitz-class or Ford-class carrier makes it nearly impossible to sink with conventional missiles, a single hit to the flight deck would likely disable the catapults and arresting gear. In this hypothetical outcome, the carrier would be unable to launch or recover its FA-18 fighters, rendering the multi-billion-dollar platform strategically irrelevant for the remainder of the engagement. Conversely, the losses on the Iranian side would likely be near total. Defense analysts suggest that for every successful strike on an American vessel, dozens of Iranian fast boats would be destroyed. If the engagement were to occur, the combination of the carrier air wing's Hellfire missiles and the destroyer's 5-inch deck guns would likely turn the surface of the strait into a graveyard of burning composite hulls. In a hypothetical 3-hour engagement, wargame models predict the loss of over 80% of the participating Iranian fast attack craft. However, in the logic of asymmetric warfare, these losses are often viewed by adversary planners as an acceptable trade. Analysts emphasize that the Iranian Revolutionary Guard Corps Navy is not designed for fleet preservation. If the loss of 60 fast boats and 200 sailors results in the mission kill of a United States aircraft carrier and the withdrawal of its strike group, Iranian Doctrine would likely categorize the engagement as a strategic victory. In this scenario, the exchange ratio favors the side that can replace its losses more easily. Building another fast boat takes weeks, while replacing a carrier's combat capability takes years. The exchange would also likely result in the loss of several United States naval aviators. If MH-60 Sierra helicopters were to remain in the dead zone to provide cover for the fleet, they would be exposed to a wall of heavy machine gun fire and shoulder-fired surface-to-air missiles from the swarm. Analysts suggest that the loss of 2 or 3 helicopters would be a likely outcome of such a close-quarters engagement. This reality highlights the honest cost of littoral combat, an environment where the technological distance between the hunter and the hunted is reduced to nearly zero. This phase of the analysis concludes that modern naval warfare is not a game of perfect defense, but a game of managed attrition. In this hypothetical, while the United States Navy would likely maintain its position in the strait, it would do so with a damaged shield and a compromised spear. This analysis is based on publicly available data regarding armor, warhead yields, and defensive success rates. Real outcomes would depend on the specific location of impacts and the effectiveness of damage control teams. But the data indicates that no side would emerge from the strait unscathed. In this hypothetical scenario, the engagement would likely conclude not with a formal surrender, but with a state of mutual exhaustion and a dramatic shift in the tactical landscape of the Strait of Hormuz. As the sun rises over the northern Persian Gulf, wargame analysts suggest that the United States Navy would likely remain in control of the shipping lanes. But the price of that control would be visible across the entire formation. Based on known capabilities and the intensity of the modeled swarm, the most significant outcome would be the status of the aircraft carrier, while the massive hull of the vessel would almost certainly remain afloat. Analysts believe it would likely be mission killed. In this hypothetical, a combination of at least one cruise missile impact on the flight deck and significant fragmentation damage from near misses would likely render the catapults and arresting gear inoperable. For the United States Navy, a carrier that cannot launch or recover its FA-18 fighters is no longer a tool of power projection. It is a liability that must be escorted out of the combat zone. The escorting screen would likely show even more severe signs of the engagement. Analysis suggests that one of the Arleigh Burke class destroyers would likely be forced to withdraw under tow or at significantly reduced speed. If the ship's Aegis radar arrays were destroyed by the swarm's saturation fire, the vessel would be unable to defend itself against further attacks, requiring the carrier group commander to divert remaining assets to protect the crippled destroyer. Defense analysts estimate that the United States would suffer the loss of several MH-60 Sierra helicopters, and potentially 2 to 4 carrier-based jets shot down or lost due to the inability to land on the damaged deck. On the Iranian side, the outcome would be a tactical catastrophe but a strategic talking point. Wargame models consistently predict that between 80 and 90% of the participating fast attack craft would be destroyed. Based on the distributed lethality doctrine, this means hundreds of crew members and dozens of vessels would be lost within a few hours. The remaining survivors would likely withdraw into the shallow, rocky inlets along the Iranian coastline, where the United States Navy's larger ships cannot follow. However, the primary question of the engagement, could Iran close the strait, would likely be answered with a no in the short term, but a yes in terms of global impact. In this scenario, while the United States Navy holds the physical water, the mission killing of a multi-billion-dollar aircraft carrier would likely cause global insurance rates for shipping to skyrocket, effectively closing the strait to commercial traffic through economic means. Analysts suggest that the victory would be perceived differently by each side. The United States would point to its continued presence in the waterway, while the Iranian leadership would point to the physical damage inflicted on the world's most powerful naval platform. Ultimately, the engagement would likely end in a tactical stalemate, where both sides withdraw to reassess. The United States Carrier Strike Group would likely move toward a friendly port in the region for emergency repairs and damage assessment, while Iranian land-based forces would remain on high alert, preparing for the inevitable strategic response. This outcome is based on the reality that modern naval weapons have reached a level of lethality where even the winner of a high-intensity battle would likely suffer losses that would have been unthinkable in previous decades. In this hypothetical scenario, defense analysts suggest that several critical lessons emerge from the engagement between the United States Navy and the Iranian swarm. These findings, based on modeled data and known capabilities, offer a sobering look at the evolution of modern maritime conflict in restricted waters. The first and most significant lesson is the magazine depth paradox. Wargame models indicate that while the Aegis combat system is technically capable of intercepting nearly any individual threat, it is physically limited by the number of interceptors it can carry. In this scenario, the use of $1 million Standard Missile 6 and Standard Missile 2 interceptors against relatively inexpensive fast boats and drones creates what analysts call a catastrophic cost-exchange ratio. If the United States Navy is forced to expend its highest-tier munitions early in an engagement, it may find itself vulnerable to secondary waves of more sophisticated cruise missiles. Analysts suggest that future doctrine must prioritize the development of mass for mass, utilizing low-cost interceptor drones or directed energy weapons to preserve high-end missiles for high-end threats. Utilizing low-cost interceptor drones or directed energy weapons to preserve high-end missiles for high-end threats. The second lesson involves the littoral clutter challenge. This analysis highlights that in a narrow waterway like the Strait of Hormuz, the primary advantage of the United States Navy long-range sensing is partially neutralized by geography. If this engagement were to occur, the proximity of civilian shipping and the rugged Iranian coastline would likely provide radar shadows that allow an adversary to close the distance before they can be effectively targeted. This suggests that in the littorals, tactical victory depends less on the power of a ship's radar and more on the decision cycle speed of the crew. Analysts believe that future engagements in such environments will require a higher degree of decentralized command, allowing individual captains to fire without waiting for fleet-wide coordination. The third lesson centers on platform vulnerability versus mission survival. Historical precedent and current models suggest that while a United States aircraft carrier is nearly impossible to sink, it is surprisingly easy to mission kill. In this hypothetical, a single hit to the flight deck or a direct strike on a critical sensor array would be enough to remove the carrier from the fight. This analysis teaches us that a win for an asymmetric force does not require the destruction of the American ship. It only requires the disruption of its capability to project power. Analysts conclude that the Carrier Strike Group's current defensive posture, which focuses on protecting the hull from sinking, may need to evolve into a strategy that prioritizes deck protection and redundant sensor architecture to ensure the mission remains viable after taking a hit. These lessons indicate that the future of naval warfare in contested choke points will be defined by damage logistics rather than simple tactical superiority. This analysis is based on publicly available information regarding weapon systems and known military doctrine. Real outcomes would depend on factors no model can predict. But the data suggests that maintaining a presence in the Strait would require a fundamental shift in how the United States Navy manages its ammunition and protects its most valuable assets. In this final phase of the hypothetical analysis, wargame analysts suggest that the immediate tactical silence in the Strait of Hormuz would likely be followed by a profound and lasting shift in the global balance of power. If this engagement were to occur as modeled, The strategic consequences would extend far beyond the narrow waters of the Persian Gulf, forcing a fundamental reassessment of how modern superpowers project force in contested environments. Based on the projected outcome of a United States victory achieved at a heavy cost, the most immediate implication would likely be the demystification of the aircraft carrier. While the carrier would likely remain afloat, its status as a mission-killed platform would likely be used by adversaries worldwide as proof that saturation doctrine can neutralize American naval supremacy. Analysts believe that the sight of a multi-billion-dollar capital ship being towed toward a repair facility would likely embolden other regional powers to invest more heavily in anti-access and area denial capabilities, such as mobile missile batteries and low-cost drone swarms. The strategic fallout would also likely manifest in the global energy market. In this scenario, even though the United States Navy would technically hold the field, the physical damage to the fleet and the persistence of the threat would likely result in a prolonged closure of the strait to commercial traffic. Defense analysts suggest that the insurance blockade would be more effective than any physical Iranian minefield. If global shipping companies refuse to enter the Gulf due to the risk of being caught in the crossfire, the Iranian objective of economic disruption would be achieved without the need for further kinetic action. For the United States Navy, this hypothetical engagement would likely trigger a massive shift in procurement and deployment strategy. Wargame analysts predict that the Pentagon would likely accelerate the move toward distributed maritime operations. This would involve moving away from a reliance on a few large, expensive platforms like aircraft carriers and toward a larger number of smaller, unmanned, or minimally manned vessels. The goal would be to ensure that no single successful strike from a swarm can compromise an entire mission. This analysis suggests that the era of the carrier-centric Navy might be forced to evolve into the era of the networked flotilla. If this engagement were to conclude as analyzed, the political landscape in the region would be fundamentally altered. While the Iranian Revolutionary Guard Corps Navy would have suffered near total tactical losses, their ability to inflict damage on a superpower would likely be framed as a strategic success for their domestic and regional audiences. This would likely lead to a new period of high-intensity deterrence, where both sides are aware that any future engagement would result in unacceptable losses. Analysts believe this balance of blood would replace the traditional balance of power, creating a more volatile and unpredictable security environment. Summary of outcome. In this hypothetical scenario, the United States Navy would successfully maintain its presence in the Strait of Hormuz and neutralize the majority of the Iranian swarm. However, the cost would be the mission killing of a primary aircraft carrier, the severe damage of at least 2 escort vessels, and significant losses within the carrier air wing. The Iranian force would be effectively neutralized as a maritime entity, but would achieve its strategic goal of demonstrating American vulnerability and disrupting global commerce. Key analytical lessons: saturation versus help. Sophistication. Quantity has a quality of its own in restricted waters. Even the most advanced defense can be bypassed if the volume of threats exceeds the physical number of interceptors. The fragility of power projection. Capital ships are increasingly vulnerable to mission-kill strikes that do not require sinking the vessel to achieve a strategic result. Geography as a force multiplier. Littoral clutter and coastal terrain remain the ultimate equalizers against technological superiority. The economic blockade. In modern conflict, the perception of risk can be as effective as a physical barrier in closing a strategic choke point. The United States would hold the strait, but at a price that would shock the American public and fundamentally change the calculus of future deployments in this region. This analysis is based on publicly available information regarding weapon systems and known military doctrine. Real outcomes would depend on factors no model can predict. This is a hypothetical scenario based on known military doctrine.